Okay, let's take a look at a multiple regression problem. Um, we'll use an example, um, problem 49. It's on page 737 and 738 of your textbook. Um, Multiple regression is just, all regression is predictive. That's basically what we use it for. We want to predict something that's going to happen in the future. Now in simple regression, we predict a dependent variable based on changes in an independent variable. With multiple regression, we still have one dependent variable. That's the thing that we're trying to predict. But we're recognizing that it may be affected by more than one independent variable. In this case, we've got a bunch of tires, and we've gathered data based on a customer survey, and they rate the tires based on two criteria. One is steering, or say handling. So some tires make the car steer or handle better than other tires do, and the higher the score, the better the steering with that tire. And the other tire characteristic that we're measuring is tread wear. So if the tire lasts a long time before it wears out, then customers give it a higher score. If it wears out quickly, customers give it a lower score. And then finally, we ask the customers whether or not they would be interested in buying that tire again, which is kind of a satisfaction score. And the higher the number, the more likely they are to purchase that tire again the next time they need tires. So, of course, the first thing we have to do is we need to decide what's the dependent and what's the independent variable. And in this case, what we're trying to predict is, the willingness of the customer to buy the tire again. We say that's the dependent variable, or Y. So we'll call the buy again variable Y. That's a dependent variable, and we'll say it's based on a combination of criteria: steering, which we'll call independent variable 1, and tread wear, which we'll call independent variable 2. Okay? So we have two independent variables. We could have 3 or 4 or 10. Um, you know, there could be a lot of relationships as to why people would want to buy these tires again or not. And that's what makes it multiple regression. Now, simple linear regression with one independent variable is comparatively easy to do mathematically, and super easy to do on Excel. Multiple regression is frankly very difficult to do mathematically, but super simple to do on Excel, and that's what we're going to do now. So let's look at the problem. It gives us this data. I've supplied this data to you. If you want to work along with me, you can just pause now and pull up a sheet. And the first part of the problem is, it says develop an estimated regression equation that can be used to predict the buy again rating based on the steering rating at the 0.05 level of significance. Test for a significant relationship. Okay, so in this case we want to find out if there's a significant relationship with alpha at 0.05. So first we're going to do, we're just going to compare the buy again variable based only on the steering variable. So I'm going to show you could do it the way I showed you in the last chapter, but I'm going to show you a different way to do it now. Go up here and you click on data, and then you move over here where it says data analysis, and you click on that. And these are all the data tests that it gives you, and one of them is regression. So I'm just going to click on regression, say OK. Now it wants to know what my Y is, so insert the Y range. So the Y is buy again. I'm going to include the label, so I'll just do this. And then I'll go back up here and click this little button. And then it said, what's X? So in this case, X is just going to be steering. So I'll click on that, go over here, include the label, and go back and click on the little button again. Okay, and I'm going to click label so it will label the variables in the output. I can put confidence level in here. I can put 0.05. Well, it'd be 95% confidence. Okay, and then click here where it says output range, like where do I want to see the results, and I want to see them right here. And then I click OK. And give it a second, and it gives me a bunch of information here. Now the question is, how do you read all this? I'm just going to expand this a little bit. So there's a lot of information here. Some of it you're not going to need, but let me just highlight some things that you'll want to take a look at. So for instance, this is R for the model. R is the correlation coefficient, and we can see that the correlation coefficient is 0.91, so we can say that the steering rating and the buy-again rating are highly correlated. We can look at R squared. The R squared is the coefficient of determination, and we can see that this is basically the steering is 84% of the buy-again decision. So that's very high. This adjusted R square makes certain adjustments based on the number of variables and the sample size and so forth. So adjusted R square, we're going to use that to compare models to see which model is better. So if we were predicting this buy-again decision, just based on this model, it has an adjusted R square of 0.83. If we're comparing it to another model and has a higher adjusted R square, then that other model is better. If it would have a lower R square, that means the other model would be lower. Okay, let's go down here to here is our slope and intercept. So here's the intercept. It's minus 7.52, and here is the slope of the line. It's 1.81, and I want to look over here at the p-value to see. So we're doing our significance basically. So 7.8 e minus 0.8 is a very, very small number. I'd move that decimal place over 8 spaces, so it's 0.000000 whatever. So since alpha is 0.05, this number is much smaller than 0.05, so we can say that there's high significance. Okay, so let's highlight that. Okay, so that basically, so in part part A, we've done part A, and at 0.05 level of significance, test for significant relationship. We say yes, the relationship is very significant. B, did the estimated regression equation developed in part A provide a good fit to the data? Well, yeah, the good fit is the R, and R squared shows that that the equation fits the data very, very well. Okay. All right, and then so that's basically simple regression. I have one independent variable. So now in part C, it wants to develop an estimated regression equation that can be used to pick the buy-again decision given steering rating and tread wear. So now I want to compare this to using both independent variables. So we're just going to do the same thing again. We'll go to data. We'll click on data analysis. We'll do regression again. The y value will stay the same, but the x value will change. So now I want it to be both. So I'm just going to highlight both of them, both steering and tread wear, because I have two independent variables. Okay, and the output will change. We'll put that down here so we can compare them. Okay, so here's my output for two variables. So let's look at these same things. So here's my correlation coefficient, which is 96%. Compared, or 0.96 compared to 0.91, so the correlation is even higher. Here's my correlation of determination, I'm sorry, my coefficient of determination. It's 0.93 compared to 0.84. Here's my adjusted R-square. This is the one I said you could use to compare models. So I have two different models here. One simple regression, one multiple regression, and I can see that my adjusted R-square is higher for the multiple using two independent variables than it was using one independent variable. So this is actually a better model. It's a better predictor of the buy again rating. So I can tell that. I can go down here and I can look at my overall significance. Um, yeah, so skip that for a minute. So I can go down here. So here's my coefficient, and here is my slope of the steering line and my slope of the tread wear line. Okay, so my formula would equal. So it would be the buy decision or buy again decision equals my slope, so it'd be minus 5.39, say, plus 0.69 times steering plus 0.91 times wear. Okay, and that would be my predictive formula. That's my regression formula for this problem. So that's what all this is. Now I want to go over here and I want to look at the p-values for my independent variables. So again, at a 5%, if I'm looking at an alpha of 0.05, so my p-value for steering is 0.029, significantly less than 0.05. So that's highly significant. And my tread wear p-value is 0.0005, which is much lower than 0.05. So these are both. So this relationship is highly significant at the alpha equals 0.05 level. So, like I said, the math is kind of difficult if you're going to do it, mathematically. But Excel, as always, makes things simple. So I think if you understand that, I think you can do the homework. Good luck.